Thank you for joining us for today's Kenworth Northeast Training Academy. Today, we're going to take a deep dive into after-treatment. My name is Melinda. I'm the Director of Marketing here at Kenworth Northeast. And more importantly, we are joined by our trainer, Tom Williams from Skyline, and our sales rep, Rafat. So cameras and audio are defaulted to off to reduce background noise and distractions during our session today. So when you have a question, pop them into the Q&A and we'll make sure to address them as we go throughout the call. In addition to today's training, we've also got a great lineup of events going actually through October of this year. So if you've not had the opportunity to check out our other sessions, you can find them online at kenworthne.com/events. Before we do get fully started, I just want to let you know, like I said, Tom has a lot of really great content to take us through today. If we do go past 3 o'clock and you're not able to stay on, we are recording the session and a recording will be available to you. I'll shoot it out by email within the next day or so as well. So with that, Tom, I will go ahead and kick it over to you.
All right, let's get this screen. All right, hello everybody. My name is Tom Williams. I am the trainer at Skyline Emissions. I got this position by default. I started my career as a diesel mechanic and kind of just slowly moved my way into this. I've been doing this presentation for about the last 2 years. And that's just a little bit about me. So as far as this presentation, I'm going to try to shorten it up a little bit, but it's all going to be there meat and potatoes wise. We're just basically going to go through this stuff. I give a basic history of why and how we got here, as far as what led to needing after treatment on there. Go through how the system works as far as DPF, DOC, the SCR, DPF, and DOC failure modes, maintenance, and then some replacement parts stuff. I don't go through any error codes. That is a week-long or 2-week-long, 3-week-long class, right? But this is basically trying to get us to think about DPF, DOCs in a different way and what really changed or changes engine-wise to make failures happen, and how can we stop some of those things and make it to where our DPFs last longer. A little bit about our group. We've been around since '98, started in Canada, started with retrofit stuff. We have our own emissions testing lab. We test all of our filters to make sure that they comply with what we deem to be EPA's guidelines. And make basically the best product that we can. As far as where we came from, everything started in the early 90s, late 80s, early 90s. Every engine that was out there on the road looked like this. Oops, sorry. Plume of smoke coming out of a stack. It was how everything was. The old adage was, if it's not smoking, it's not making horsepower, and that was true then. What they did to get this plume of smoke was they mechanics and owner operators would basically block off return lines, change parts in the pump to make it to put more fuel into the cylinder, right? The main reason why they wanted to get rid of this is that EPA deemed this as visual smoke pollution. The difference between this cloud of smoke and a cloud of smoke that you'd see coming out of a deleted truck or a truck that has a broken DPF is basically the size of the particulate matter. This particulate matter was large and very clumpy, very wet with fuel, and would fall down to the ground. Whereas now, with the high fuel pressure that we have in engines, that cloud is very small particulates and will stay basically suspended in the air indefinitely. As far as why emissions went on there, the two main things that we are trying to take care of are the particulate matter and NOx. Those are the two main things, the main reasons why we have all these things on our vehicles. As far as how PM is produced, PM is produced by the droplet size of the fuel. The smaller the droplet size, the smaller the particulate matter that's emitted from the exhaust. Back when we were getting those large flakes of soot coming out of the exhaust stack, that fuel pressure was 1200 psi coming out of the tip of the nozzle. Nowadays, we are upwards of 30,000 psi as far as the injection pressure. That has a huge it makes the sorry, it has a huge difference as far as the particulate matter that is emitted, right? So when we are atomizing the fuel better with higher fuel injection pressure, it makes smaller particulates, right? So they did a bunch of things to engines to make it to where we weren't getting these large clouds coming out of the exhaust. One of them being high injection pressures. The other one being high cylinder temperatures. The cylinder temperatures basically were dictated by the timing. They advanced the timing to the point where the cylinder temperature would increase to the point where basically everything was atomized and used up, right? So all the fuel was used up. We went from really poor fuel economy to really good fuel economy when injection pressures increased and cylinder temperatures increased, because now we're using all of the fuel for power. Whereas before, it wasn't using all the fuel, it was being wasted in the cylinder and combining with all the soot inside the cylinder and making large particulates that would come out of the exhaust. So as our new injectors start to wear out, they wear out mechanically a lot quicker than they do electronically. One of the most misdiagnosed things in a diesel engine is a mechanical failure of an injector. People overlook it all the time. It is one of the most leading causes of DPFs clogging, DOCs clogging, having EGRs sticking, things like that, are injectors that are failing. Right here, we can see that this is a really good, fine injection spray pattern, whereas over here, not so good, right? Now, just remember that the droplet size of this and how we're atomizing the fuel totally, absolutely makes it to where less particulate is created, right? Because it can combust. Just imagine if you had a large droplets like this versus more of a cloud that goes into the cylinder. You can combust that cloud all at the same time, whereas the fuel droplet just combusts and continues to smolder and burn as it's being ejected on the exhaust stroke. The particulate size that we're talking about as far as the what drove DPFs to be on vehicles, this is a good representation of that. Very little of these particulates were available back in the old days with mechanical injection. It was all larger particulates, bigger than this. The three main ones that we're trying to take care of are PM10, PM2.5, and ultrafine particles. The main difference between these is that 2.5 and PM10, our bodies can protect us from those. Our nose hairs stop PM10 from going into our bodies, and inside of our lungs, we have hairs that are called cilia, and those basically stop PM2.5 from getting into the lining of our lungs. Ultrafine particles, which is the majority of the soot that comes out of the engine nowadays is ultrafine particles. Those will actually make it past our body's defenses and make it to the lining of our lungs, not only attached to the lining of our lungs, but be absorbed into our body and then get into our bloodstream. That is the main reason why DPFs had to go into place, as far as why they needed to have after treatment, was because of these small ultrafine particles. As far as some of the things that they did along the way, all these things are part of the emissions package, if you will. We have the first thing that they did was common rail injection, high pressure with controllable injection, meaning they adjust the timing through the injector, EGR, DOC, DPF, SCR, and that includes DEF, right? As far as how the regenerations work, there's two different types of regenerations. There's a passive regeneration. Passive regeneration means just that. There's nothing else that happens while to make a regeneration go. Regeneration meaning oxidizing soot and turning it into ash. Passive regeneration is basically taking exhaust gases, and at certain temperatures through the DOC, it changes them from NO to NO2. NO2 is a higher oxidizer than just oxygen alone, or NO by itself. So it quickly oxidizes soot, can even oxidize it through the DOC, so that way there's no soot in the DPF. Regeneration in itself was meant for and made solely for passive regeneration. The DPF itself does not want to have soot in it, right? Soot is bad for a DPF. Passive regeneration helps and basically makes it to where DPFs don't have soot in there. It will actually convert and oxidize the soot as it goes through there. This is one of the main reasons why over-the-road trucks don't have near as many problems with DPFs as around the town or cold duty cycle vehicles. Anything that has a colder duty cycle relies almost solely on active regenerations. Active regeneration is just that. Something active is happening, and it's usually actively injecting diesel fuel into the exhaust stream, and it turns that into smoke, makes that smoke has a reaction against the DOC, then that causes heat. And the rapid increase of the heat transfers into the DPF and then oxidizes the soot after that. The main reason why we don't want soot in a DPF is that it is sticky. It sticks together. It causes it to clog. It causes restrictions, and it causes other issues like ash bridging, things like that to happen. So passive regeneration is the best way to go. So if you have vehicles, then you're not driving them down the freeway, try to get them to go on the freeway for as long as possible. It will help a lot as far as if you're having DPF issues with your trucks. All right. The first iteration was in 2007. This was super simple. We had an auxiliary injector, DOC, DPF, 2 thermocouples, and then a differential back pressure sensor. This was very simple in its design, excuse me, but really difficult to diagnose. We had a lot of issues with this just because the software wasn't up to speed yet. Error codes didn't make sense. Trouble trees didn't make sense. It was really hard to diagnose from this point. Yeah. But during that time, as far as the after treatment, they knew that they had an issue. They had problems with NOx. And they knew that they needed to do something different with that. NOx is formed in what's called the high temperature zone. So as the emissions were coming about and they started increasing the cylinder temperature basically introduced NOx into the exhaust stream. NOx was never available in diesel engines before this. This was actually created by us because we increased the cylinder temperatures. So NOx is created, so the hotter the fuel combusts, or the higher the cylinder temperature is, the more NOx is created. It's created in what's called the high temperature zone. And that's as soon as the fuel droplet combusts, that's when NOx is created, because as soon as it combusts, it starts instantly trying to cool down. The main first thing that they tried to do to get rid of NOx was EGR. EGR basically is exhaust gas recirculation. It takes exhaust gas, opens a valve, small amounts of exhaust gas go through an EGR cooler. That cooler basically introduces water and CO2 into the cylinder because of condensation as it's cooling down. That cooling down of that cylinder creates a lower NOx because the cylinder temperature, we're bringing the cylinder temperature down, right? As we're bringing that cylinder temperature down, it does reduce NOx, but there's a trade-off. That trade-off is that PM production, or hydrocarbon, the soot production, goes up because we're reducing the temperature, right? So hotter the temperature, the ability to combust completely the fuel and create less particulate matter, right? So as we are using EGR, NOx numbers goes down, PM numbers go up. It's transverse, right? So EGR closes, NOx goes the opposite way, so it goes up, and PM production goes down as the EGR is working. So that's why EGR is always going to have a percentage of EGR. It's not just going to be open for all the time. It's not going to be closed all the time. It has to open and close, so that way it is not producing more NOx or more soot in other times than not, or all the time, I mean. Because they realized and knew that they had a problem with NOx, they came up with another solution. That solution was SCR, selective catalyst reduction. How it works is pretty simple. It takes urea, or DEF fluid, injects it into the pipe. It goes through this decomposition tube. The decomposition tube is meant to dry the liquid, and it turns it into gas. That gas is ammonia gas. That ammonia gas has a reaction with the SCR catalyst and basically neutralizes NOx. There's two NOx sensors, one before, one after. Most of the new ones now have the NOx sensor up by the turbo. But the NOx outlet NOx sensor is always going to be after the SCR, so it tells the differential. And then we have a thermocouple that's right here. The thermocouple is there to make sure that we're not injecting DEF fluid at the wrong time. DEF fluid needs to be injected when it's hot, so that way it can actually convert that liquid and turn it all into gas, so that way we don't get problems with coking, that white coke that builds up through the decomp tube and on the SCR face. That was in 2010 that this came out. 2013, in my opinion, the best thing for diesel happened. We finally went to OBD. OBD has been around since the 90s in gas vehicles, and finally in 2013, we got it in diesels. It opened up a whole bunch of diagnostic tools for us. We actually had functional tests that were available to us now. Everything was modular. We made it to where our data streams were a lot clearer. We had better data and better tools to help us diagnose things. This is basically what we have now. Everything is pretty much the same as what was on the 2010, except for we have a lot more sensors all over the engine. One of the cool ones that I thought that was good, it's not pictured here, but it's EGR cooler differential pressure. I think that's awesome because before that, you had to rely on temperatures to kind of lead you down the path that the EGR cooler was plugged. And then the other thing that is the best thing that they could have done was this NH3 catalyst that they put on after the SCR. NH3 is the chemical makeup for ammonia. So they put an ammonia scrubber after the SCR because during injections of DEF into the exhaust, it was possible that the SCR was not absorbing all of the ammonia gas, and that gas was coming out of the tailpipe. Ammonia gas, in case you don't know, is very poisonous and can kill you within a matter of minutes. And they had some people experience getting very ill. A couple people had died from inhaling ammonia at the exhaust pipe. During this time, that's when basically went out across the nation. Don't be around the exhaust pipe during regenerations. Don't ever regen a vehicle inside of a shop, things like that. And that was because of the ammonia gas. That was because they were having people with getting health problems and getting sick because of ammonia gas poisoning. So don't put your face by the exhaust. Even still today, don't do it. There still is a possibility that some ammonia could come out of the exhaust pipe. All right. So this says DOCs are helpers. I think that word is should not be on there, but they do the heavy lifting. Nothing happens in a regeneration without the DOC, right? The DOC does everything in the regeneration. It is the main thing that causes us to oxidize soot and turn it into ash, right? When it's an active regen, diesel fuel turns the heat. When it's in passive regen, oxygen and nitrogen, it converts through there and turns into NO2. All DOCs are catalysts. Catalysts mean that they are flow through. They do not have any filtration. Catalysts also have a wash coat on there. That wash coat helps with mixing, right? So there are hills and valleys in the wash coat that help create turbulence through the DOC. Turbulence is crucial for mixing, and that mixing is the creation of NO2 and the creation of heat when we are actively injecting fuel. DOCs are made mainly of ceramic material. That ceramic is pretty much every single filter now. They used to have some metal ones, but pretty much everybody uses the ceramic ones now versus the metal. As far as NO2 creation, NO2 is the peak of NO2 creation is at 300 degrees Celsius. This right here on this graph kind of shows you why over-the-road trucks have less problems with DPFs. They sit right around here while it's going down the interstate. They are constantly creating NO2 and constantly have their after treatment system in a regeneration state. It is constantly regenerating, constantly oxidizing soot and turning it into ash as it's going into the DPF, right? No need for active regenerations typically while it's going down the road. It's just doing it seamlessly and 100% in passive regeneration. When we do need to get into an active regen, this is kind of what it looks like. It'll start injecting right just north of 200 degrees Celsius and inject to get those temperatures up to maximum NO2 creation, right around 300 degrees C, right? It'll also inject a little bit after that, right? So it'll pick up injecting right around here, pick up injecting here, and try to get it to where it'll be in passive regeneration. Because when we're injecting fuel, we are creating hydrocarbons that are possible to be in the DPF. So we're having to oxidize those as well as all the other soot that's either trapped in the DOC or trapped in the DPF. DPFs are what's called a wall flow filter. Wall flow meaning that on the exhaust inlet side, we have openings into channels that are blocked off on the outlet side. So everything goes in, all solid material stays inside those channels, and then just the exhaust gas go through the cell wall and then out of the exhaust. Two different types of materials. There's cordierite, silicon carbide. The main difference between these two is that silicon carbide is a lot stronger of a material. It can withstand a lot more temperature as well. It's segmented in individual bricks and cemented together, whereas cordierite's just one gigantic brick. The main difference in use, you will start seeing and probably have seen a lot more silicon carbide filters on newer vehicles, and that's just because they meaning the OEs have increased temperatures and times for regeneration, which cordierite could not handle the temperature of those, especially if there is any other materials inside of there. Where silicon carbide can handle all those things really well. So that's why you'll see more silicon carbide than cordierite moving forward. A lot more companies are starting to use it. Why they didn't use it in the beginning is that it's a little bit more expensive than cordierite. All right, so talked about active and passive regeneration. This is the active regeneration. This is the automatic regeneration while you're going down the road. Just giving you I'm a graphs guy. I like to see things on a graph. So this is what it looks like while it's going down the road. We have DOC inlet temperature, which is the blue line. We have DOC outlet temperature, which is this red line right here. You can see that right here, it's constantly trying to regenerate. It's constantly trying to do an active regeneration, right? And that's because the back pressure sensor is telling, hey, we need to do something about this soot. We have too much back pressure. We need to get that pressure down, right? So you can see right here that we have this injection right here. This is a really, really good one. It starts injecting, and then we get a differential temperature rise of about 150 to 200 degrees difference. That's Celsius, by the way, so 400 plus degrees Fahrenheit difference between these temperatures. And that is there just so that way it can quickly heat up and oxidize that soot by using heat, right? But this is what it looks like while it's going down the road doing a regeneration. When it comes to stationary regions, every stationary region looks exactly like this. There's always going to be a long wait period before it starts injecting. This is the most important time, right? And that is because it's looking for, can I start injecting, right? Are all my sensors good? Is the engine good? EGR functions good? Everything's warmed up, NOx sensor wise, everything's good to go. Yes, I can inject. Starts injecting, sharp rise in temperature, and it holds that temperature for a preset time, and then goes through and finishes the regeneration. This was a successful one. If it's going to fail a regeneration, usually it fails it within here because of a back pressure sensor, temperature sensor, something like that that causes it to say, hey, we don't have the right conditions. The right conditions are not met for regeneration, so we have to fail it, right? After regeneration, stationary regeneration, anything that's in that filter should all be ash. All the ash is from lube oil. The lube oils have additives that are put in there to aid in lubrication of the engine. And those additives are metals, and that ash is basically the metals that cannot be combusted at the temperatures that we are doing regenerations, right? So as that ash collects inside of the filter, we get what looks like this, right? So after time, you have less and less room for soot to go into that filter, right? This is when, let's just say for argument's sake, that this is when right here at the end is when your vehicle's ECU will say, hey, it's time to pull this filter and get it cleaned. In my opinion, and what we've seen out in the field, is that this and waiting for a vehicle to tell you what to do is waiting too long, right? Usually when you go to pull a filter, and let's say you have vehicles that are non-over the road and you have colder duty cycles, vehicles that have a lot of idle time, this especially applies to you, because usually what happens is that when you go to pull that filter out, it has a problem. It's cracked. It's melted. It has some other issue. It's face plugged. This is a thing that I believe that was not talked about enough in the very beginning when these vehicles came out. Those times are meant for over-the-road vehicles, not cold duty cycle vehicles, right? So a lot of those times, I would say cut them in half, clean your filters early, clean them often. It has a lot more benefits than it does negative effects. One of the benefits is back pressure is detrimental to diesel engines, right? As we build back pressure, all that soot and pressure starts building up against the engine. We have a lot of turbocharger actuation issues, right? Where it cokes up inside of a VGT or the actuator and causes the turbo to need to be replaced. We have a lot more EGR issues the longer we go with our DPF service, the more EGR issues that we have down the road. It affects valve seals. It affects everything upstream from it because it's creating back pressure and causing unneeded pressure and clogging upstream, right? So cleaning your filters early and cleaning them often is a better practice than waiting until it's too late, basically. So the SCR system basically takes DEF, injects it through the decomp tube, goes through the catalyst, and what comes out is N2 and H2O. There is a temperature range. That range starts at 200 degrees Celsius, 400 Fahrenheit. If we have DEF fluid that's in that pipe, it's because if it's injected before this temperature is reached, then we have problems like this. We have severe coking that is capable or basically clogs up the filter, clogs up the pipe, and causes us lots of issues with back pressure on everything, right? So if you see any of this, there's a good thing to note that even if you start seeing light white like drops or a stain inside there, make sure that you take your injector out, make sure that it's not dripping, do that DEF injector test on there, make sure that we don't have DEF going into the SCR when it's not supposed to be there. All right, so there are two different ways that DPFs fail. They crack and they melt. Main way that they crack is like this. 90% of all filters that I see that come back to us that are cracked, they are cracked because of this. Let's say that you have a filter that the face is all black with soot, and then the outlet side is perfectly clean, looks like you could eat off of it, right? There's no soot coming out of it. But then you go to clean it, and that cleaning as they're blowing it out and getting it clean, you start to see soot coming out of the filter. It's because of a scenario like this, and it's due to cold duty cycle, and lack of regenerations, right? So for this purpose, we have our exhaust coming in. It's a 90-degree exhaust going through the DOC. As the exhaust comes in, it goes up to the top of the inlet, and it will always find center. Exhaust always finds center. It never goes up and then stays up at the top. It'll always find center, right? So with that said, let's say this is a cold duty cycle stop and go trash truck around town, right? So what happens is it's going down the street, everything starts to heat up, then it stops to pick up bins, right? So what happens is that as you're driving, it is starting to do a regeneration here, right? But what happens is this heats up, this does not, and then soot starts to pile up on the outside edges all the way around the circumference of that filter and creates a cold environment, right? Cold environment because no exhaust can flow through here, right? No NO2 can get in there, no oxygen can get in there, no fuel can get in there, nothing can get in there. So what happens is, as it starts to do a regeneration, it will do a regeneration here and then expand. This starts to expand out. This expands a little bit less, and this does not expand and starts micro cracks from the outside edge of the filter in towards the inside, right? So as you take this filter out, that's where they would start blowing this way to get all the soot out, right? And it would start blowing through here because they started to uncover these cracks, right? These cracks can get even so bad that they will get into where it's flowing inside of here. But this is 90% of every filter that I've seen out there that cracked was because of this way. And it's every single one of them was a low duty cycle around the town vehicle. How we stop some of these things is to get onto more of a maintenance program, preventative cleaning of filters, preventative stationary regens, things like that. If you know you have a fleet that has cold duty cycle stuff, try and figure out when is the best time to do this, especially if you have filters that are failing a lot, because we can do some things about that. It just is going to take more time and more effort to stop these filters from failing or to slow them down, right? So that's how filters crack. Filters melt. Every melted filter is because of foreign material being fuel, oil, anything like that that gets inside of the filter, coolant. Every single one of those gets hotter than just fuel when it goes through regeneration. So once it starts to heat up and it starts to actually burn that oil and get to the point where it's got its flash point, it will actually start melting that filter. So anytime you see a melted filter, it's 100% because of foreign materials.
Hey, Tom, really quick, we do have a question
Yes.
from the audience. It says, will there be DEF fluid injection during an active regen?
Yes, there can be.
Okay.
Because the NOx sensor sees that that there's more NOx being created.
All right. Let us know
Cool.
if any other questions.
All right.
All right. Thanks, Tom.
Mm-hmm. All right. So just some other pictures. This is a melted filter, piece of cordiorite. This picture right here is a great example of that ring that I was telling you about, how it gets plugged up with soot. This is the outlet side of the filter. You can see that soot is coming through in the middle, but there's nothing coming through on this side of the filter right here, right? All the way around this filter, it's completely plugged. You've seen this a bunch of different times, and it's because of cold duty cycle, 100%. Some melted filters, one really melted filter where the outlet side of it completely came apart. Another really good picture of that plugging all the way around, how it starts to plug, but the regeneration and the flow is right in the center of the filter. This is a really big problem. I see more filters like this than any other scenario. And then another melted filter. All right, so as far as DOCs and the catalysts, they have wash coats on them. I said in the beginning that all the wash coats have hills and valleys in it, and that creates turbulence, right? So this is one of the main reasons why when it's going through that DOC, we get such quick response and quick mixing of gases and expansion of heat through that DOC. It's because of these hills and valleys. As the catalyst starts to go away and gets older, there's a couple things that can happen. You can get surface erosion, where the catalyst just completely starts to move. Catalyst just completely disappears, or you can get sintering, right, where the wash coat will just start folding over on itself. The majority of the time, though, we get it to where it's like this, where ash and sulfur and soot can actually cover and block the active catalyst from being out in the open. This can be solved by cleaning the DOCs. Cleaning the DOC is as important as cleaning a DPF. They should be done in tandem. You should never replace a DPF and not clean a DOC. Having a brand new DOC on there and then a dirty DOC, just basically the first time you start that engine after replacing that DPF, all that soot that's in the DOC is just going to go right into that filter, that brand new filter. And now you're behind the 8-ball. Now you have soot that's inside that filter that needs to be regenerated when you could have had both of them be perfectly clean and have a longer life with both of them, right? So the best way to keep your DOCs good is to get them clean and have them inspected.
All right,
All
Tom,
right.
really quick, we've got another question.
Okie dokie.
When you have a face plugging of the DOC, what causes this issue?
Well, usually face plugging, it depends on what the soot makeup is, right? So if you are cleaning your filters regularly, you can see changes in soot, meaning the soot used to be super dry. Now it's starting to feel a little wet. And you can tell how that feels a little bit by the look of it and by the feel. Does it feel slimy or does it feel just a little wet? Is it fuel? What does it smell like? Things like that, right? But face plugging usually is because you have no flow through the filter. It just basically plugs up into the DOC, or you have so much soot coming out of the engine that there's no possible way for all of it to go into the DOC through the DOC and get into the DPF. So what happens is it will start to pancake on the outside face of the inlet face of the DOC and just spread out, right? So just imagine. So DPFs and DOCs are meant to work on perfectly good running engines. They're not meant to work and to filter engines that are in disrepair. And by disrepair, I mean engines that have mechanical issues like valve seals that are putting oil into the cylinder, injectors that are not atomizing fuel the correct way, turbochargers that aren't spooling up the way they should, things like that, right? So if we're putting too much soot into the DOC and DPF, then we're going to cause it issues, right? So there's a couple different reasons why, but those are the two main ones, right? Either you have too much soot or not enough flow through the DPF and it just starts backing out.
All right, thank you.
Yep. All right. So this is where we get into a lot of that stuff, kind of the recap, right? So engine aging, just make sure that we know that the longer we wait between cleaning a filter, the worse it is for the engine, right? Back pressure is a diesel engine's worst nightmare. I can tell you that hands down. Diesel engines have always hated back pressure. So when we're creating back pressure by not cleaning the filter, we're creating other problems that cause a lot more expensive repairs, right? As the DOC starts to degrade and starts to go down, this is where we get some of the catalyst efficiency codes. It will start trying to inject more. It will start asking for more regenerations and stuff like that because there is no passive regeneration through there because it's not converting into NO2 as well as it should, right? As far as if you have a DPF that has failed, the worst thing you could do is just throw a part at it without trying to figure out what caused it, right? DPFs do not fail on their own, right? They have things happen to them, and they're all caused by other stuff. DOC is not working correctly, engine is having an issue, or just plain and simple lack of maintenance, right? DPFs and DOCs should always be thought of as a maintenance item from the very beginning. Even when they're brand new, they should be thought of as a maintenance item, and that's where we can get back to having million-mile engines with no problems. It's because we don't do enough maintenance, right? And it has nothing to do with anybody that it's just not talked about. It's not out there. Like I just put it out there. But anyway, so if you are replacing a DPF and you don't know why, then that replacement sometime is going to suffer the same failure because you have something else going on upstream. Whether it's cracked or melted, something else is going on upstream. If you have a DPF that's just plugged, that is not an actual failure. A lot of times you can get that cleaned, and if there was nothing else that happened inside there, like a crack formed or anything like that, then you can put it back on the vehicle and go about your time, right? As far as cleaning and doing all the cleaning your filter and maintenance on your DPF stuff, cleaning early, in my opinion, is always the best. I am 100% for maintenance and over maintaining things, right? Maintenance on DPFs, I've said it a bunch of times, and you're going to hear it a couple more times throughout this, but making sure that you clean your DPFs is paramount. Paramount. You will have a lot less problems with engines if you got on a cleaning regiment, right? Having swing filters, people say all the time, well, the downtime is an expense too. Well, have a swing filter. Have a spare one sitting on the shelf that you can throw in there to send your other filter out to get cleaned. I have a bunch of customers out there all over the United States that are on regimented cleaning cycles, and they don't have problems with their engines anymore. All right, so things to take away. Failures happen even though there's no check engine light. We have a lot more mechanical things going on in engines than people remember, right? We have to remember that we still have a mechanical aspect to diesel engines. It's not just our laptop, right? It's the laptop and the sensors give us an indication of that something's going on for the emissions side. But we have mechanical issues that happen that there is no sensor that picks it up, right? Valve seals starting to put oil into the cylinder. There's no sensor for that. We have wiper rings that's not taking all the oil off the cylinder wall. We're getting more oil up on top of the piston. There's no sensor for that. There's no sensor for the injector tip worn out, right? Where we are not atomizing the fuel as much, right? So there's a lot of these mechanical things that cause problems downstream with the DPF that have no sensor that says a laptop can tell us, right? This is one of the main reasons why I say if you're pulling your filters, you can see the change in the soot makeup, right? You can see that it's gone from good dry soot, fluffy soot to now it's wet, or now it looks like it's all cracked, or it looks like, what does it feel like? What does it look? Is there an abundance of it? Is it super thick? Or is it just like a light dusting of soot on your DPF and DOC, right? So making sure that we are remembering that there are mechanical issues that cause damage, and they happen really quick, especially just like we had that question, face plugging of a DOC. It can happen super fast where, within minutes, you can plug a DPF if you have enough soot coming out of an engine. Treat DPF and DOC as a maintenance item. That is super important, hands down, probably one of the most important things. That if you take anything away from this, please take this away, that DPFs need to be maintained. They should have been maintained a lot more often, especially in colder duty cycle engines. Use soot to determine if you have an engine issue, kind of beat that one. And the droplet size is the key to soot production. Your injectors mechanically failing. These are the top four that I talk to people about the most, right? So there we go. All right. So as far as the company goes, we have been in business for a long time. We have a emissions test laboratory where we test everything. We use all OEM suppliers for all of our stuff, and we really do truly strive to make the best product out there. We try to make our stuff better than or equal to the OE filter, right? We have a 3-year warranty, unlimited miles. Just remember that we do not warranty performance-based issues that are caused by engines, right? So as far as our company, when we get a new product in, we break it down to its basic roots and make a drawing of it. We completely redo the filter. We redesign it. One of the main things that we do and what we strive to do is constantly improving on others' designs. Every single Skyline filter out there gets this ring and wire rope gasket that goes underneath there. It's on both sides of the filter, the inlet and the outlet of the filter. It is there to hold the filter in place. A lot of times when you start having a face plug of a DPF or an SCR, DOC, what happens is the back pressure will build up to the point where you'll start sliding that filter out of the housing. Well, with a Skyline filter, it's not possible because there's a retaining ring in there and that filter won't slide out. If the filter slides out, basically it's done. You need to replace it with another one because that matting is broken, and you will, just a matter of time, have soot leaking past that matting and getting downstream from the DPF. But we try to keep it to where our filters last the longest. That's why we put a retaining ring and the rope gasket underneath it. We also do a couple of big things. We take designs and make them better. We do improvements on them. This is from Max Force school buses. This is what's called the Tootsie Roll. We call it the Tootsie Roll filter. The inlet and outlet are usually attached to the can, but we took it and we made a different version of it to have flanges so that way the inlet and outlet can be removed for cleaning. We had several school bus companies that were when they cleaned these, they were cutting the inlet and the outlet off It was costing them a lot of money to get the filters cleaned and cleaned properly. So we took that upon ourselves and made it to where now it is modular. They can pull the filter out. If it does break, it's a lot less expensive to replace just this filter versus the entire unit, things like that, right? So I take pride that we do things like this a lot. Our filters look good. They weigh really close to what the OE filter weighs. And we pride ourselves on our welds and our appearance, not only with just the filter, but how it comes packaged in the box as well. Every filter goes through a pressure check before it gets tagged and moved out for sale. Every single filter has to pass this test. If it doesn't pass, then it doesn't go out. And that's it.
All right. I got one more question for you. Uh,
Okay.
what are the time frame or mileage to have the DPF or DOC cleaned with a highway vehicle versus a city vehicle?
So I would look up your engine manufacturer's manual and what their guidelines are and cut those in half. I would start literally thinking about cleaning filters before 100,000 miles, before 50,000 miles. And honestly, it really depends on there's a cement truck fleet that their trucks, they only put like 7,000 or 8,000 miles on their trucks in 1 year. But the majority of the time, they're only going a couple hundred yards. They fill up, they go dump because they're on local jobs where they move the batch plant around, right? So these things, they don't get any miles, they get a lot of hours, right? So do the hours conversion if you have a lot of idle times, things like that, and then cut whatever numbers that they say at minimum, cut the number in half. So if it's 300,000 miles, do 150, 120,000, 100,000. But seriously, start to look at cleaning your filters as a scheduled maintenance thing at least once a year. Doing it while it's a scheduled thing is a lot less expensive than doing it when it's an emergency.